Hello, so as per the assignment, I was tasked to make a video about each law in action, and unfortunately, I was absent during the day of the lab, so I'm going to do all the physics stuff in my room. Okay, I'm going to begin with the first law. What is the first law about? Poof! So, Newton's first law, it's all about an object stay still and it cannot move at all, or it could be in motion. And another object, such as this, could act upon another one, such as this object right here. Let's call it object A. This object, let's call it object B. This moves toward that, and therefore this moves this direction because that acted upon this. And how we see this applied will be in the following whatever object I come up with. Okay, recall how there was an object A and object B. Object B acted upon object A. This will be object B, this will be A. So A is just chilling here. Object B is going all over the place. And then notice where object A goes. It naturally goes down, probably because of Earth's gravity. However, if I take object B now and I just flick it upward, look at what happens to object A. It goes in the complete opposite direction now. But Newton's first law isn't about the object going in an opposite direction, but rather about a different object influencing the velocity of another object. So that is sort of what Newton's first law is about. Newton's second law is all about the degree of force you put upon another object and how that force influences the acceleration of the object. But it's not the force alone that influences the acceleration, but also the mass of the object itself. So what that means is take this 1 pound object, cube, whatever, and then we put in 10 units of force upon it. Okay, it's going to move this direction in 1 meter per second. So it's as a result of this imposing force upon this, that this will now move this way at 1 meter per second. And there are multiple ways that this could change. First is if you change this. The higher this goes, the higher this will go. And the lower this goes, as a result, the lower this will go as well. So that is what force, that is a change that force has on acceleration given an object. However, another way that this could change is if this changes as well. So in spite of us still having the same 10 units of force placed upon an object, let's say it's 10 pounds now, the result will now change. I don't know the maths on this, but 10 leads to 1 to 10. 10, 10, what, this should be 1 meter per second now, I think. So that is what the second law of motion is about. And of course, it's not going to stick to whole numbers. There's going to be much more complexity to that. And, it's not going to be exactly 1 pound. It's not going to be exactly 10. It's going to be in decimal form and more complex units, not pounds. It could be kilograms or mm, pico picometers per second. But how does this apply with an object now? All right, I will continue to use badminton as an analogy. So there's the birdie, And then there's a teddy bear. Both of these weigh differently, but they both still have the same gravity. So, how the hell could you determine the weight? One thing that could be done is estimate the weight, not determine. I use the same force, I apply the same force upon both of those objects. So, both of those objects being the birdie and the teddy bear. So, I'm going to apply this amount of force on both of the objects. And with that, you could estimate which object is heavier, either the birdie or the teddy bear. Okay, I'm going to apply this force to this now, the birdie. It went up very fast. Look at that. Now, let's apply similar force to the teddy bear now. Oh. Well, that's unfortunate. But that should give you a good idea on which object is heavier than the other. And based off of that little experiment there, this is allegedly heavier than this, even though I applied the same exact force on both of them. And of course, it's more complex than that. It's not just isolated to a racket. Anything, literally everything, could be applied here, and it doesn't just influence one thing. There's also air molecules. You heard that? That whiffing sound, it interacts with air molecules as well. Pretty cool. All right, the third law now. This law is all about how instead of it viewing as an object putting a force upon another object, so something as simple as this, instead of the interaction being from A to B, what is actually happening, according to this third law, is the objects interact with each other. And what the hell is that about? How do you conceptualize that? Well, the easiest way I would view it is in the form of cars. So let's say this one is going 60 miles per hour, and then this one 100 miles per hour. Oh, now it makes more sense. Now that these two objects are in motion and they're headed toward each other, kabow, they both influenced each other in some way. This gets all messed up and this gets all messed up as well. And it's easy to think that because of this, acting upon this, only this will get messed up. But what isn't realized is that along with the fact that this gets messed up, this too gets messed up as a result of the influences that they had upon each other. So when I punch a wall, one might think that the wall breaks, which it might, but my fist might also break as well. So that's what I believe the third law is about. And what do we end up seeing here in badminton? Okay, what is badminton about? Racket hits birdie, and then birdie goes in the direction based off the angle and force and gravity of which is imposed on the birdie. Now, one may think that, oh, only the racket is influencing the birdie. That isn't the case. Look closer at this racket, and there's actually wear and tear on it. And that's actually a consequence of what? Me hitting the floor, me hitting a wall in accident, me hitting myself with the racket? No. It's actually as a result of the sheer force being placed upon the birdie that the force is actually going back onto the racket and damaging it over time. So that should give you a good idea on the practical effects that the third law of motion has on the object exerting its force. It's not the victim that gets influenced, but also the attacker as well. Okay, this is my rough understanding of Newton's three laws of motion. And in the first law of motion, there's most emphasis placed on velocity. And the first law of motion could also be described as inertia. And it's all about a different object influencing the velocity of another object. The second law has emphasis placed on acceleration and how acceleration changes based off multiple factors, and those factors being the mass of the object or the weight and the force that is being placed upon the former object in which acceleration outputs. And that is Newton's second law. And the third law has emphasis placed upon reciprocity, on how it's not that an object influences another object and only the victim gets influenced, but it's more about how there's an interaction between how they influence each other. And the best way to conceptualize that idea is two cars slamming into each other or someone punching a wall. It's all about how they reciprocate, not a straightforward approach. And that is Newton's third law.